4 is find the state space form for a system governed by the following differential equation. And so again, I didn't say which method you had to use, so you can choose which one you like. Alright, so our differential equation, y triple dot plus 4y double dot 7y dot minus 9y plus equals 15u plus u dot. So this is another one of those with the derivative of the input. I think first let's just go ahead and do it by our kind of brute force define the variables and carry things out method. Let's start with x1 equals y and x2 equals y dot, and then our third state we'll have to take care of this u dot. So x3 is going to be y double dot, and if this comes over to the side it will be minus u. And so then that will say that x3 dot is y triple dot minus u dot, and we can use this equation over here, rearrange, bring the u dot to that side and these other terms to the right hand side. We get minus 4y double dot minus 7y dot plus 9y plus 15u. Okay, we can use our defining equation here, solve it for y double dot. We get x3 plus u. Now it can be substituted in over here. So let's do a little more rewriting here. x3 dot is negative 4 y double dot. Y double dot is x3 plus u. So just remember this is y double dot. And then minus 7 y dot. Y dot is x2. Okay. And let's see, plus 9y. Y is x1. And then plus 15u, u is u. Okay. And what? Negative 4x3 minus 4u minus 7x2 plus 9x1, 15u. So our u's will combine to give us, what, 11u. Alright, and our x2 equation, x2 dot equation, is what? X2 dot is y double dot, and we solve for that up here. Y double dot is x3 plus u, and then x1 dot is y dot, which is x2. Alright, so we've got our states defined nicely, and then our output equation is just our first state defining equation. Y is x1, so we can write our ABCD matrices. A and B. Let's see, we'll put down here. Alright, so our first equation, our first row in A and B is our x1 equation, x1 dot equation. The coefficient of x1 is 0, coefficient of x2 is 1, coefficient of x3 is 0, and there's no b, so, there's no u, so our b coefficient is 0. Second equation for x2 dot, nothing for x1, nothing for x2, a 1 for x3, and a 1 for u. And then our x3 equation, x3 dot equation, coefficient of x1 would be a 9, x2 negative 7, x3 negative 4, and u looks like 11. And then finally for our output equation, y is x1, so there's a 1 coefficient for x1, x2 and x3 have a 0. There's no u, so d is equal to 0. So there's one way to do that problem.